And finally, page 3. So tell whether or not these ratios are proportional. The easiest way, actually, I guess I shouldn't say the easiest way. There are several ways we could do this. You could take 1/3 and then take 7 over 21, which is number 1, by the way. And you could sit here and think, 1 times what number would equal 7? Well, okay, that's 7. And 3 times, well, it had better be 7 to be 21 for us to be able to say, yes, that's proportional. So we talked about this last week when we came back from spring break to say, can we even do any of this stuff? And the answer is yes. We can tell whether they're proportional by multiplying. But let's do the next one. So this one, let's zoom in to conserve some space here. 3.5 over 2 and 14 over 8. Well, this is an example, in my opinion, where I'm just kind of hoping that it's 2 times 4 and 3.5 times 4. But I'm not going to do that on this one. I'm going to force myself to divide. So 3.5 divided by 2. And if you're like, why did he write it like that? This goes to that. And I show this is this because when I was your age, this tip made me go, oh, you know what? If I write it like this, the 2 is automatically on the outside of the division symbol. And that was helpful for me because I would always screw up where it went. So 2 goes into 3 one time. 2 goes into 15 7 times. So this fraction is equivalent to 1.75. I didn't know that just looking at it. Actually, I guess I probably could have figured that out. But anyway, let's keep going because now what we're going to do is 14 divided by 8. So there's 14. How many times does 18 go into 14? 1 time. With 6 left over. There's an invisible decimal. Bring down this 0. 8 goes into 60. Let's see. 8 times 7 is 56. There's our decimal, and we have 4. Oh my goodness. 8 goes into 45 times. So this fraction is also 1.75. So yes, this one is also proportional. Now, if you're looking at that going, that took 1,000,000 years to do. Listen, that's why I started off by saying maybe I shouldn't say which one is easier, because maybe you were like, actually, no, that one was very nice, very easy. Okay, then do it, right? Because I think what I would probably rather have done, like I said, was 2 times 4 is 8. What's 3.5 times 4? Well, 5 times 4 is 20. 4 times 3 is 12. Oh, it's 14. And that would have been so much faster. But you'd have to know how to do that. You'd have to know you could do that, right? You'd have to know what's going on here. And you might. And so, cool, do it. So number 1 and number 2 are yes. Number 3, 0.6 over 0.5 and 12 over 10. Now I'm going to do the method. I'm going to write it over here. I'm going to label it before I actually do it. This was the cross. Okay, so what you do is you multiply diagonally. So 10 times 0.6, 10 times 0.6 is 6, just so you know. And 12 times 0.5, 12 times 0.5 is 6. So this one is also yes. Am I just trying to trick you in that all of them are yes? We'll find out. So we'll find out by doing the next one. 1/5, 6/30. With these, I was about to say with this one and these came out. With this one, I don't really want to do the cross multiplying one. I don't want to do dividing. I can pretty clearly see that 5 times 6 is 30. And 1 times 6 is 30. So since they are both multiplying by the same number, I'm good. But at the same time, it wouldn't have been that bad to do 5 times 6 is 30, and 1 times 30 is 30. So there were 2 ways to check this in very short time. So, I mean, if you look out at our kind of 3 examples, which one do you like? I think there's some clear winners here. I think multiply and the cross are quite nice, but hey, you do what works for you. 24 over 30 and 3 over 7 over 2. Now, I included this one because of how ugly it looks and because there's no way you're going to say, I can just multiply. And maybe you will, because you know that 3 times 8 is 24. So is 7 over 2 times 8 30? Let's try it. 7 over 2 times 8. Well, that'll be 8 over 1, which is 56 over 2, which is 28. Nope, because that's 30. So this one is just, no, that one's not proportional. Could you have done it another way? You could have done the cross. 3 times 30 is 90, and 7 over 2 times 24, 7 over 2 times 24. 2 goes into 24 12 times. 12 times 7 is 84. So 84 does not equal 90. So again, this is a no. 2 to 4. 2 to 4. 11 to 11 over 2. This one's pretty clear. And well, hang on. Sorry. This one's shouldn't be so clear. My mind, for some reason, told me that, 2 times 2 is 11. Or it was not really saying 2 times 2 is 11. It was like 2 times 11 is 22. But that's not how this is working. So, let's do the cross on this one, because there isn't a pretty clear number of like, you could multiply this. So 4 times 11 is 44. So what we're hoping to get is when we cross these two, we also get 44. 2 times 11 over 2. Well, these 2's cancel, giving us 11. So hopefully it was pretty obvious that no, this one was not going to be proportional, just by kind of looking at that being a very simple proportion of 1 over 2. I know it says 2 over 4, but that could be rewritten as 1 over 2 or 1/2. That's not 1/2, right? It's just not. And if you're like, okay, smart guy, what about the division version? 11 over 2 is 11 divided by 11 over 2, which is keep, change, flip, and the 11s cancel, giving you 2. Okay, so this part of the ratio or proportion, this part, it's 2, and this one was 1/2, and that's another reason why it's no. Okay, so we just did the first 6, and let's do the next 4. Tell whether they are proportional. Well, I love number 7, because here is the nicest guy, because it tells us that 7 is the rate. So what that means is this is 2 times 7, and we should be getting 14, but we really are not, right? And it should be 3 times 7 and getting 21, but we really are not. So this is a no. And in fact, but wait, Mr. Math, we're going up by 1 each time. Yeah, you know what? You are right. So if we are going up by 1 plus 1 plus 1 plus 1 plus 1, let's go down. So if we subtract 1, we get 6 for y and 0 for this one. The picture of that guy looks like this. 1, 2, 3, 4, 5, 6. 0, 6. And then the rest of them look like this. That's a straight line. Is it going through the origin? No. So there you go. 8. Well, dang. I don't have any, I can't see the unit rate right away, but I like to sometimes do things that overlap. Check it out. 4 over 10. 4 over 10. The rate here, the rate is 2.5. How'd you get that, Mr. Math? Because 4 times a number equals 10. I can figure that out if I divide both sides by 4. And 10 divided by 4, or 10 divided by 4 is 2.5. Don't believe me? Go watch the first video. So, is 2 times 2.5, is that 5? Well, we might have to actually do that math. 2.5 times 2, actually, no, I guess not. If you just double 2.5, it's 5. Okay, if you, and now I'm not going to be able to double 2.5 because it's times 6. But if you think about it, 2.5 times 6, 30, 12, 15. Oh, look, it's 15. So, yeah, we are good. This one is proportional. Okay. Is it proportional? I don't know. I don't see my rate right away. I would only see my rate right away if x was 1, and I don't have that here. I do have it here, so that's kind of nice. A little preview. So what are we going to do? Well, it's 0.25 times some number is going to give me 4. Now, you might actually be able to figure that out because I love, so here's another thing I love to do. Use money type of talk. Or easy to use fraction type of talk. So if you think about it, if you have 25 cents, it takes 1, 2, 3, 4 to get $1. And then if you have $1, it just takes 4 times that to get $4. So check this out. 4 times 4 is 16. That's our rate. Now, if you're like, what? What just happened? Money and I don't know. Well, okay, like I said, we could divide both sides by 0.25 and do this. 4 divided by 0.25. When we actually divide like this, we're going to have to move the decimal twice. And so really it's 25 into 400. So 25 goes into 40 once. 25 goes into 150 6 times. So, I mean, either way, we got 16. So the idea is that this number times 16 gives you 4. This number times 16, does it give you 8? Yeah, because half of 16 is 8. Is 3/4 of 16 12? Well, let's find out. Actually, we don't really need to quote-unquote find out, because if we're using proportional thinking, this goes up by 0.25. This goes up by 0.25. That's going up by 4. That's going up by 4. That is a constant rate. Okay? And if you're like, but wait, what about that whole origin thing? If we go down 0.25, if we go down 4, we would get 0, 0. So, yes, this one is proportional. Last one is our rate is 3 over 5 because x is 1. So our rate is 3 over 5. What are we going to do to see if the others work? Because 2/3 and 4/3, well, we could do 2/3 times 3/5. And what would we get if we did 2/3 times 3/5? Well, let's just go straight across and find out. 2 times 3 is 6. 3 times 5 is 15. Is that 7/10? No. So now, down here, it's asking you to pick 4 of the proportions above. By the way, there are 6 to choose from. And if you're like, what? Well, there's 6. Let me show you. There was a 1, a 2, a 3, a 4, a 5, a 6. There were the 6 to choose from, right? And it just says, hey, give scenarios. Here's your hint. Think chocolate bunnies and Easter eggs. So I'm just going to do the very first one. 1 to 3 and 7 to 21. I buy my friends 1 pizza. Hang on. The wording on that is going to be funky if I say I bought my friends 1 pizza for each 3 games we play. Sure, that sounds good. And then if we were to now go with the proportional version of that, I'm going to buy my friends 7 pizzas for every 21 games they play. So I buy my friends. My handwriting is really awful because I'm really just trying to be fast. And because I'm speaking, and if you can't hear me, then I'm sorry. I buy my friends 7 pizzas for each 21 games played. And if you're like, what kind of friends and pizza is this situation? That's not the worry, okay? So, boom, we did the first one. Let's do the next one. 3.5 to 2. I buy $3.50 for each. Here, how about not I buy, I spend. I spend $3.50 for 2 donuts. Spend $3.50 for 2 donuts. But I can also spend $14 for 8 donuts. How's that? Well, it was because of this, 14 to 8. We just did the second one. 0.6 to 0.5. Let's see. Every 0.6 gallons contains 0.5 oranges. Well, let's scale this up. Let's change it up a little bit. So then every 12 gallons has 10 oranges. I really wanted to change up the wording on this so that you could see that the logic stays the same. Because right here, 4 each. 4. But this one doesn't say 4. And on the next one, I'm going to use that one magical word we love, per. So let's just do this one right here because it's the quarter one. And if you're like with the quarter one, I spend 25 cents per 4 minutes of car washing. That would be a really cheap car wash, by the way, in case you guys have never paid for your own car wash. And then to just switch it up, okay, you pick literally any of the others. And then I spend 75 cents per 12 minutes of car wash. So, that is the entire practice test. If you have questions, if any of this is still fuzzy, you gotta come talk to me. You gotta reach out. I'll see you later.